Hi, I'm Professor Dow. Today I'm talking about some of the research projects that I'm currently involved in and others are working with me on. There are two rooms in the structures lab. There's a shaking table room that's on that side. I'll talk about that first a little bit. On the shaking table room, I designed with the help of my students, graduate students and undergrads, as well as a technician, the shaking table machine. It's a unique machine. It's capable of applying larger accelerations than have ever been recorded in an earthquake. And it's capable of applying over 4 feet of displacement. So we tell a computer, this is the earthquake we want to apply, and the table moves at any given time to exactly where it is. So it can be a real earthquake motion, or it can be a simulated earthquake, or it can represent an earthquake at the 20th floor of a building structure. It could be either measured or simulated. We could take a measured ground motion over time and build a structural model, for example, and see what happens on the 20th floor, and then take that result and apply that to the shaking table. And if you happen to sit on it, which you don't want to do, you'd roll right off the table. But if you sat on and hung on, it would feel exactly like the 20th floor swaying back and forth. You would feel all that behavior. So it's not just the ground motion, the shaking table, but it can represent a bridge structure or any other behavior, not just down at the ground. Over on this side, this is current research that we're doing. The big testing machine behind me, I designed that again with the help of undergraduate and graduate students. We had some undergrads from Brazil that were here, and they helped quite a bit as well on the project. See, again, a unique machine. We can apply over 1 million pounds of force to fail steel ship panels in compression, which is like this until they fail, and they fail in large displacements. It's like a slow motion car crash. And then we also, so that's compression, and we also fail them in shear like this. Those are prior projects, and the current projects is in compression, but it's the United States Navy that's now interested in our projects because it's already changed all commercial shipping design codes, not just in the United States, but across the world. And so now we're looking at, again, the US Navy asked us to, has come in and asked us to do fatigue testing on this. So we're literally cycling it as fast as we can. For smaller coupons, we're cycling it at 10 cycles per second. So back and forth 10 times every second. And it takes hundreds of thousands of cycles, sometimes millions of cycles of loading to fail them at this given stress level we're interested in. And we're looking at specific cutouts and welded details. And over on that table, we have a bunch of coupons, some that were just finished testing yesterday, another test is going to be started tomorrow. These coupons are representative of small portions of these big swage panels that we're actually testing, these ship panels that are about 8 feet by 8 feet with swages built into them.